We talked about dark forest, the idea that staying silent saves us, that survival means hiding in the cosmic shadows, making ourselves invisible to predators lurking in the void. But what if the real danger is the opposite? What if staying still gets us trapped forever? If these explorations intrigue you, a like or subscribe helps, but let's continue. This is the Grabby Aliens Hypothesis, and it's not another theory about why aliens might kill us. It's about why we're already losing a race most people don't know we're in. Here's the core idea. Right now, civilizations across the universe might be expanding outward at nearly the speed of light, not exploring, not visiting, claiming. They're spreading through space, establishing territory, transforming stars and planets into infrastructure, and every region they reach becomes permanently theirs. We call them grabby civilizations, not because they're hostile, but because they grab cosmic real estate. They expand, they settle, they transform. And once they've claimed a region of space, that region is no longer available to anyone else. Think of it like a land rush. Settlers lined up at the border waiting for the signal. When the gun fired, they raced to claim territory. First come, first served. Late arrivals got nothing, except in this version the starting gun already fired, possibly millions of years ago, and we're still at the starting line. The universe isn't empty space waiting patiently for us. It's territory, and it's being claimed right now. Here's what makes this urgent. The amount of universe we can reach is shrinking every single second. Not because the universe is getting smaller, but because the longer we wait, the less we can claim. Every year we delay is millions of cubic light years we'll never touch. Every century is entire galaxy clusters moving permanently out of reach, not because they're too far, but because someone else will have gotten there first. This is geometry, the mathematics of cosmic expansion combined with the speed of light, and it suggests something unsettling. Humanity's long-term future might be determined in the next few centuries, not millions of years from now. Now. Dark Forest says the universe is full of predators. Grabby Aliens says the universe is full of settlers and the frontier is closing. Dark Forest says survival means hiding. Grabby Aliens says survival means claiming your stake before there's nothing left to claim. We're not facing a threat. We're facing a cosmic race. This isn't about asteroids or nuclear war or climate catastrophe. This isn't about survival. It's about potential. It's about whether humanity spans galaxies, or whether we stay locked in one tiny solar system while the rest of the universe gets divided up among those who moved faster. The territory is vast, but it won't wait forever. Every second we delay, the reachable universe shrinks. But to understand what we're racing against, we need to see how fast Grabby really is. When a civilization decides to expand, how fast can it actually go? The answer is terrifying in its simplicity, nearly the speed of light. Not through some exotic physics or warp drives, through basic engineering that's theoretically within our reach right now. Self-replicating probes, von Neumann machines, robots that can build copies of themselves from raw materials. Here's how it works. You send a probe to a nearby star system. It arrives, mines asteroids for resources, builds copies of itself, and sends those copies to the next star systems. Each new probe does the same. 1 becomes 2. 2 becomes 4. 4 becomes 8. Exponential growth. A single civilization using this method could colonize an entire galaxy in just a few million years. That sounds like a long time to us, but cosmically, it's nothing. A blink. The universe is 13.8 billion years old. A few million years to fill a galaxy is like claiming an entire continent in an afternoon. And the expansion doesn't slow down, it accelerates. Because each new outpost becomes a launch point for more probes. The frontier doesn't advance linearly, it explodes outward in every direction simultaneously, at a significant fraction of light speed. Think about what that means. If a civilization started expanding just 5 million years ago, a time frame where Earth was still waiting for humans to evolve, they could have already claimed thousands of galaxies. The entire local galactic supercluster could be theirs. and we wouldn't necessarily see them coming. Because the expansion happens at relativistic speeds, the probes move almost as fast as the light announcing their arrival. By the time we detect evidence of their presence, they're already here. Distance doesn't protect us. It accelerates the land grab. The farther away a civilization is when they start expanding, the more territory they can claim before anyone else even knows the race has begun. Now here's the crucial point. This expansion creates a sphere of influence that grows at near-light speed. Everything inside that sphere gets transformed. Stars harvested for energy, planets converted to infrastructure, raw materials processed into more probes. It's not subtle. It's not quiet. Which brings us to the critical question. The observable universe contains trillions of galaxies. The reachable universe, the fraction we could colonize even if we started today, contains hundreds of billions of stars. But here's the constraint. That reachable fraction is finite, and it's shrinking. Because the universe is expanding, galaxies are moving apart, and due to dark energy, that expansion is accelerating. Every day, more galaxies cross the cosmic horizon, the boundary beyond which they're receding faster than light, unreachable forever no matter how fast we travel. Right now, we can theoretically reach about 20 billion light-years worth of space, but in the future, less, much less. The reachable universe is a closing window, getting smaller with every passing moment. And if grabby civilizations are expanding at near-light speed, they're claiming that finite resource faster than the universe can take it away. This is the race. Not against other civilizations directly, we might never meet them, but against the geometry of space-time itself, against the ever-shrinking boundary of what's cosmically possible. If expansion happens this fast, why don't we see evidence everywhere? That question reveals something crucial about timing. Grabby civilizations aren't just expanding, they're impossible to miss. Think about what advanced expansion actually looks like. A civilization spreading through space doesn't just plant flags and move on. They transform everything they touch. They build Dyson spheres around stars to capture every photon of energy. They disassemble planets for raw materials. They create computational megastructures, energy collectors, communication networks spanning light years. This isn't science fiction speculation. This is engineering necessity. Any civilization advanced enough to expand across star systems needs energy, vast amounts of it. And according to thermodynamics, you can't use energy without creating waste heat. The more advanced they are, the more energy they use, the brighter they glow. A Dyson sphere, a structure completely enclosing a star, would be one of the most obvious things in the night sky. The star would dim in visible light but blaze in infrared. It would look wrong, unnatural. A massive infrared beacon screaming artificial structure here, and it's not just Dyson spheres. Stellar engineering of any kind leaves signatures. Stars being moved, planets dismantled, megastructures blocking starlight in patterns that can't be explained by natural phenomena. Mining operations, manufacturing, computation generates heat, communication leaks signals, a civilization transforming star systems can't hide. Thermodynamics won't let them. So we've looked. The most comprehensive search scanned 100,000 galaxies looking for exactly these signatures. Galaxies glowing with waste heat from advanced civilizations. The result? Nothing. No anomalous infrared emissions. No galaxies that look engineered. No evidence of stellar-scale construction anywhere we can see. We've looked at individual stars too. The Kepler Space Telescope monitored thousands of stars for years, measuring their brightness with extraordinary precision. If a Dyson sphere was being built around any of them, we'd see the star's light gradually dimming as the structure grew. We found nothing that fits the pattern. The WOW signal in 1977, a strong narrowband radio signal that lasted 72 seconds and never repeated, remains the closest thing we have to a potential alien transmission, and even that is almost certainly natural interference. Decades of listening since then, silence. If grabby civilizations exist and they're expanding the way the theory predicts, we should see them. Their expansion spheres should be lighting up our telescopes. They should be obvious, unavoidable. Some of them should have already filled observable chunks of the universe, transforming billions of stars into whatever infrastructure they need. But the universe looks pristine, untouched, natural. Every star we observe behaves exactly as stellar physics predicts. Every galaxy follows the patterns of natural formation and evolution. There's no evidence anywhere of large-scale artificial activity. No dim stars, no infrared anomalies, no megastructures, no waste heat signatures from galactic-scale engineering. This creates a sharp paradox. If grabby civilizations can expand at near-light speed, if they transform everything they reach, if they've had billions of years to spread across the cosmos, where are they? It's the Fermi paradox, but more pointed. Because grabby civilizations are specifically the ones that can't hide. They're loud by definition, visible by necessity. They're doing exactly the kind of cosmic engineering that would show up in our telescopes. If they existed in our past light cone, in the region of space whose light has had time to reach us, we would know. The fact that we don't see them tells us something critical. Not that they don't exist, but that they haven't reached us yet, that their expansion spheres haven't intersected with our observable volume of space, which means either grabby civilizations are incredibly rare, so rare that the nearest one is billions of light years away, beyond our detection range, or something else is going on, something about timing. Because here's the fascinating possibility. Maybe we're not seeing grabby civilizations because we're early. Not early in Earth's history or human history, early in cosmic history. So early that the era of grabby civilizations is just beginning. The absence of grabby aliens isn't evidence they don't exist. It's evidence about where we are in cosmic history. We might be early. Shockingly, cosmically early. That sounds absurd at first. The universe is 13.8 billion years old. The Sun is 4.6 billion years old. Earth formed 4.5 billion years ago. Life emerged almost immediately after that. How could we possibly be early to anything? But here's what changes the calculation. The universe isn't ending anytime soon. The era of star formation, the period when the universe can create new stars and sustain planets and potentially host civilizations, will last for trillions of years, not billions, trillions. Current models suggest stars will continue forming for another 100 trillion years before the universe runs out of hydrogen and star formation finally stops. Let that sink in. The universe is 13.8 billion years old. It has 100 trillion years of star-making ahead of it. We're not even 1% of the way through the habitable era. We're at 0.01%. We're in the cosmic equivalent of the first few minutes after the universe opened for business. From this perspective, humanity appeared absurdly early. We shouldn't be here yet. If civilizations emerge randomly throughout cosmic history, the odds of appearing in the first 0.01% are vanishingly small. It would be like showing up to a concert venue 10 hours before doors open and being surprised you're first in line. And yet, here we are. This timing does something crucial for the Grabby Aliens Hypothesis. It explains the silence. If we're genuinely early, if grabby civilizations only started emerging recently in cosmic time, then the nearest ones might have only begun expanding a few million years ago, maybe tens of millions. Their expansion spheres would still be relatively small. They haven't had time to fill the observable universe yet. They haven't reached us. We're still in unclaimed territory, not because grabby civilizations don't exist, but because they're just getting started. The expansion waves are spreading, but they haven't collided yet. The cosmic land rush just began, and most of the frontier is still open. This solves the visibility problem elegantly. We don't see grabby civilizations everywhere because everywhere hasn't been claimed yet. We're living in the brief window between the emergence of the first grabby civilizations and the full colonization of the reachable universe. It's like looking at Earth 200,000 years ago. Humans existed, small populations in Africa. But most of the planet was still empty. No cities, no agriculture, no evidence that would be visible from space. Not because humans didn't exist, but because expansion hadn't happened yet. The potential was there. The explosion came later. We might be in that same position cosmically. The first grabby civilizations might exist right now, just starting their expansion, and we're here to witness, or participate in, the beginning of the land rush. But there's a darker implication hiding in this timing, if we're early, and if grabby civilizations are just now starting to emerge. That means the window is open right now. The frontier is available. Most of the universe is still unclaimed territory, but it won't stay that way. Every year that passes, more civilizations might reach the grabby threshold and begin expanding. Every century, more expansion spheres spreading outward at near-light speed. Every millennium, more of the reachable universe gets divided up among whoever moved first. Being early is a gift. It means we have opportunity. It means the universe is still available. But it's also a countdown, because early doesn't last forever. The window that's open now will close, maybe not in our lifetimes, maybe not in 1,000 years, but cosmically soon. And once it closes, it's closed forever. If we're this early, that changes everything about our future. But it also means we're in a race we didn't know we'd entered. Something makes grabby civilizations rare, not impossible, just delayed. If the universe has been habitable for billions of years, if stars and planets have existed for most of cosmic history, why are grabby civilizations only emerging now? Why aren't we seeing evidence of ancient empires that started expanding when Earth was still molten rock? The answer lies in what evolutionary biologists call hard steps, critical transitions that are individually improbable, not catastrophic filters that destroy civilizations, not great filters in the traditional doomsday sense, but evolutionary bottlenecks that take time to pass through. Think about Earth's history. Life emerged relatively quickly, within a few 100 million years of Earth becoming habitable. But then what? Single-celled organisms dominated for over 2 billion years before one of the most important transitions in all of biology, eukaryotic cells, complex cells with nuclei, mitochondria, specialized structures. That transition appears to have happened exactly once. Every complex organism on Earth, every plant, animal, fungus, descends from that single event. One merger between different types of cells, roughly 2 billion years ago. It took half of Earth's history to happen, then another billion years before multicellular life, another several 100 million before complex animals, another stretch before intelligence, each step individually unlikely, requiring specific conditions, fortunate timing, random chance. These are hard steps, not because they're impossible, obviously they happened here, but because they might take a very long time on average. 1 billion years, 2 billion, even longer on planets where conditions aren't quite right. This creates a time distribution. If life requires several hard steps before reaching the grabby stage, expansion-capable technological civilization, then most civilizations won't appear at the same time. They'll be spread out across cosmic history, appearing whenever they finally get lucky with all the required transitions. And here's the key insight. The Grabby Aliens Hypothesis doesn't just need civilizations to be rare. It needs them to be rare in a specific way. They need to appear at roughly the same era in cosmic time, not scattered randomly across billions of years, but clustered around now. Hard steps explain this. If there are, say, 6 critical transitions required to go from sterile planet to expanding civilization, and each one takes on average 1 billion years, then civilizations will tend to appear around 6 billion years after planets form. Not exactly 6 billion, there's variation, some will be faster, some slower, but clustered around that time frame. Earth took about 4.5 billion years. We might be slightly fast or right on schedule, or even slow depending on how the statistics work out. But the point is, if other civilizations require similar hard steps, they're appearing around the same cosmic era we are, not when the universe was young, not scattered randomly throughout cosmic history. Now. In this particular epoch, roughly 13 to 14 billion years after the Big Bang, when planets have had enough time to work through the improbable transitions, mathematicians have modelled this. Robin Hanson, the economist who formalised the Grabby Aliens Hypothesis, calculated what the distribution looks like if you assume multiple hard steps with realistic probabilities. The result is striking. Grabby civilizations should be just starting to appear in the current era. Their expansion spheres should be growing right now, but shouldn't have reached us yet, which perfectly explains what we observe, or rather what we don't observe. No evidence of ancient galactic empires because there aren't any yet. No Dyson spheres lighting up the sky because the civilizations that build them only recently emerged. The math suggests Grabby civilizations are starting to appear now, which means the expansion waves are already spreading. The universe isn't empty space waiting to be explored. It's territory being claimed in real time. Here's how to visualize it. Imagine the universe as a vast three-dimensional map. Now place dots on that map, each one representing a Grabby civilization that's just emerged and begun expanding. From each dot, draw a growing sphere. That sphere represents their expansion, spreading outward at some fraction of light speed in every direction. Each sphere is a volume of claimed space. Stars harvested, planets transformed, resources processed, and critically, unavailable to anyone else. These aren't fuzzy boundaries, they're sharp, defined by the physics of light speed expansion. Inside the sphere, transformed by whoever got there first. Outside, still unclaimed, still in the cosmic commons. The edge of the sphere is a moving frontier, advancing outward every second. Now add more dots, more civilizations emerging at different locations, different times. Each one creates its own expanding sphere. And here's where the geometry becomes crucial. Eventually, these spheres will touch. When two expansion waves meet, something has to happen. Maybe negotiation, maybe conflict, maybe they just stop at the boundary, each civilization accepting the limit of their territory. But one thing is certain, whoever arrived first gets the space. There's no shared custody of a solar system, no joint ownership of a galaxy. First mover takes all. This creates a universe that looks nothing like the empty frontier we imagine. Instead, it's a territorial map, spheres of influence, borders defined by who expanded when, regions of space divided up among civilizations that may never even communicate with each other. They just happen to expand in different directions, and the territories aren't equal. A civilization that started expanding just 1 million years earlier gets a vastly larger sphere. Because that expansion is exponential, each new outpost enables more expansion, early start times compound into enormous advantages. Think of it like compound interest but for cosmic real estate. Start early, even slightly early, and your civilization sphere encompasses millions of additional star systems. Start late, and you're boxed in by civilizations that moved faster. The territorial model also explains something important about contact. In the traditional imagination of alien encounters, we assume civilizations will meet through exploration or communication. They'll send signals, travel to visit each other, make deliberate contact. But in the Grabby model, contact happens at boundaries. Two expansion spheres growing toward each other, finally touching somewhere in between. The meeting point isn't chosen. It's determined by geometry, by when each civilization started expanding and how fast they moved. And here's the unsettling part. The civilizations meeting at that boundary might not even know about each other until they collide. No advance warning, no diplomatic preparation. Just two expansion waves, each claiming territory at near-light speed, suddenly occupying the same region of space. What happens then is anybody's guess. But one thing is clear. The civilization that arrives second has less leverage. They're expanding into space that's already claimed. They're the late arrival trying to settle land someone else got to first. These boundaries define something crucial, how much universe each civilization gets. And for us, that number is shrinking every second. Every second we wait, our potential cosmic territory gets smaller. This isn't metaphor, it's mathematics. Let's make it concrete. Right now, if humanity began expanding today, if we sent out self-replicating probes at, say, 10% the speed of light, we could theoretically reach a sphere of space about 20 billion light-years in radius. That's billions of galaxies, trillions of stars, an incomprehensible amount of cosmic real estate. But wait 1 million years, just 1 million, a blink in cosmic time barely noticeable in Earth's geological record. If we delay expansion by that amount, the reachable universe shrinks by roughly 3%. That's hundreds of millions of stars we could have reached now permanently beyond our grasp. Wait 10 million years, we lose 30% of our potential territory. 100 million years, more than half the reachable universe is gone. And that's just from cosmic expansion. Galaxies moving apart due to dark energy. It doesn't account for other Grabby. Civilizations claiming territory first. If there's even one other expanding civilization in our future light cone, every year they expand is territory we'll never get. The math is unforgiving. Our potential cosmic territory, the maximum volume of space humanity could ever control, is largest right now, at this exact moment. Every day that passes makes it smaller. Every year compounds the loss. Every century locks us out of entire galactic clusters. This is opportunity cost on a cosmic scale. We think we have all the time in the world to figure out space colonization, to solve our problems on Earth first, to mature as a species before heading outward. And maybe we do have time for survival. Earth will be habitable for hundreds of millions of years. Humanity isn't going extinct tomorrow, but the frontier's closing now. Imagine someone in 1800 deciding to delay westward expansion for a few centuries. We'll settle the American West eventually. No rush. Let's wait until we've perfected our society first. By the time they're ready, someone else has claimed it all. The opportunity didn't wait. The cosmic frontier is the same, just on an incomprehensibly larger scale. The window is open. The territory is available, but windows close. And here's what makes this especially urgent. We don't know how much time we actually have. We don't know where the nearest Grabby civilization is. We don't know when they started expanding. We don't know how fast they're moving. They could be 1 billion light years away, giving us hundreds of millions of years before we need to worry. Or they could be 10 million light years away, already claiming galaxies at the edge of what we could reach. Their expansion sphere could be growing toward us right now, and we wouldn't know until it arrives. The uncertainty doesn't buy us time, it makes delay more costly. Because every year we wait is a year we're not expanding, while somewhere out there, another civilization might be. Think about it from a game theory perspective. If we knew for certain we were alone, no other Grabby civilizations anywhere, we could take our time. The universe would wait, but we don't know that. The moment we accept the possibility that other Grabby civilizations exist, delay becomes risk. Not risk of destruction, risk of irrelevance, risk of being locked into one solar system, while the rest of the universe gets divided among civilizations that moved faster. Why soon in human terms might be too late in cosmic terms. We measure time in years, decades, centuries, but cosmic expansion happens on scales of millions of years. Lightspeed expansion waves cross galaxies in that time frame. What feels like plenty of time to us, we'll get to it in a few thousand years, is exactly the window in which we lose access to most of the universe. The urgency isn't about panic. It's about recognizing what's at stake. humanity's long-term potential, the scope of what we could become, the resources we could access, the cosmic role we could play, is being determined right now by whether we expand or stay put. But here's what makes this especially urgent. We don't know where the nearest Grabby civilization is. Somewhere out there, another civilization might have started expanding. We just don't know where or when. This is the nearest neighbour problem, and it's more unsettling than it sounds. Statistical models can estimate how far away the nearest Grabby civilization probably is. Based on the hard steps model, based on the age of the universe, based on the number of potentially habitable planets, you can run the numbers and get a probability distribution. The answer, most likely somewhere between 10 million and a billion light years away. That's not reassuring. That's terrifying in its uncertainty. 10 million light years means they could have started expanding just 10 million years ago, and their sphere could already be enormous, potentially encompassing millions of galaxies. If they're expanding at even 10% light speed, they've claimed a sphere 2 million light years in radius. That's larger than the distance to Andromeda. They could have already filled the local group, or they could be a billion light years away, so distant their expansion won't affect us for hundreds of millions of years. We'd have time, breathing room, the frontier stays open, we don't know which scenario we're in, and there's no way to know until we see them, or until they arrive. This uncertainty is worse than certainty in either direction. If we knew they were close, we'd have clear urgency to expand now. If we knew they were distant, we could plan without immediate pressure. But this middle ground, where they might be close, might be far, might have already started, might not have emerged yet, creates a strategic nightmare. Because here's the asymmetry that makes this truly unsettling. They don't need to know about us to claim our territory. Think about that. A Grabby civilization expanding outward from a galaxy 50 million light years away has no idea Earth exists. They won't for another 50 million years. That's how long it takes for light from Earth to reach them. But their expansion doesn't wait for information. Their probes spread in all directions, claiming everything they reach, transforming it, moving on. By the time they discover there was a civilization here, by the time the light from our radio signals reaches them, they've already been here, already processed the local resources, already moved past us. We could be bypassed entirely without them ever knowing we existed. This is fundamentally different from the dark forest scenario, where detection leads to destruction. In the Grabby model, you don't need to be detected to lose, you just need to be slow. You lose not because anyone targeted you, but because someone else claimed the territory first and you weren't there to contest it. First mover advantage in cosmic expansion isn't about violence or competition in the traditional sense, it's about presence. Whoever reaches a star system first gets it. Not through conquest, through arrival, and the math heavily favours whoever starts first. Even a small head start, starting expansion 1 million years earlier, translates to millions of additional star systems. The difference between starting now versus starting in 100,000 years could be the difference between claiming a galaxy cluster or being confined to a single galaxy. The statistical models suggest multiple Grabby civilizations might be emerging around the same cosmic era. Not just one, not thousands separated by billions of years, but maybe a handful, scattered across the observable universe, all starting their expansion within a few million years of each other. Which means we might be in a multi-way race. Several civilizations expanding simultaneously, their spheres growing toward each other, territory shrinking as the frontiers fill in. Where does humanity sit in that distribution? Are we early, average, late? We have no idea. We can't see the other runners. We don't know if we're in first place or last. We just know the race is happening. The nearest Grabby, civilization might already be expanding toward us. But there's something even more unsettling about this model. The theory doesn't predict we'll encounter Grabby aliens. It predicts we'll become one. Think about what the Grabby model actually selects for. Which civilizations do we observe in the long run? Which ones fill the universe and leave detectable traces? Not the quiet ones. Not the ones that stay home. Not the ones that explore cautiously or expand slowly or decide that one planet is enough. We observe, or we will observe, the grabby ones. The civilizations that expand rapidly, claim territory aggressively, transform everything they touch. Because those are the only ones that become visible on cosmic scales. Those are the only ones that matter to the territorial map. This is a selection effect. The universe might be full of quiet, peaceful civilizations that stay in their home systems, live sustainably, never bother anyone. But from a cosmic perspective, they're invisible, irrelevant to the large-scale structure of who controls what. They exist, but they don't expand, they don't grab. And in a universe where territory is being claimed, not expanding means accepting whatever's left over after the grabby civilizations are done dividing things up. So here's the uncomfortable implication. If humanity has a long-term future among the stars, if we want to be cosmically relevant, if we want access to resources beyond our solar system, if we want to survive potential catastrophes by having backup colonies, we have to become grabby. Not because we want to conquer, not because we're aggressive or imperialistic, but because that's what survival looks like in a universe where territory is finite and being claimed. The alternative is staying small, staying in one solar system, hoping nothing goes wrong, no asteroid impacts, no solar expansion in a few billion years, no catastrophic resource depletion. Hoping that whatever portion of the universe remains unclaimed after the grabby civilizations finish expanding is enough for us. That's not a strategy. That's hoping to lose slowly. And there's something almost inevitable about this transition. Once a civilization reaches a certain technological threshold, self-replicating probes, interstellar capability, the ability to use stellar resources, the question isn't, should we expand? It's why wouldn't we? The resources are there. The technology exists. The potential is enormous. The only thing stopping expansion is choice. And in a competitive landscape, even unconsciously competitive, the civilizations that choose expansion are the ones that persist. This is the self-fulfilling nature of the Grabby model. It doesn't predict that civilizations are inherently aggressive. It predicts that the ones we'll see, the ones that matter on cosmic timescales, are the ones that decided to expand. Because the ones that didn't are still sitting in their home systems, invisible, irrelevant to the territorial map. We like to imagine we're different, that humanity will be the wise civilization that chooses sustainability over expansion, quality over quantity, staying home over spreading out. Maybe we will. Maybe that's our choice to make. But if we choose that, we're choosing to be cosmically irrelevant. We're choosing to let other civilizations, ones that might not share our values, might not care about preservation, might not think twice about transforming solar systems into infrastructure, define what the universe looks like. Is that better? Is staying small and hoping for the best morally superior to expanding and claiming our stake? There's no easy answer. But the Grabby model forces us to confront the question directly. In a universe where expansion is possible and territory is being claimed, doing nothing is still a choice. And it's a choice with permanent consequences. The philosophical cost here is real. Expansion means transformation. It means taking pristine solar systems and converting them to serve our needs. It means fundamentally changing the universe from its natural state. Some would call that colonization in the worst sense. Others would call it survival and growth. But here's the deeper question. If we don't expand, and other grabby civilizations do, does the universe end up less transformed? Or does it just get transformed by someone else's values instead of ours? This raises a darker question about what grabby really means. We've been using grabby as shorthand. But what does an expanding civilization actually do? The term itself is almost sanitized. Clinical. Grabby civilization sounds like an economic model, not a description of what's actually happening when a technological species spreads across the galaxy, transforming everything in its path. So let's be specific. What are we actually talking about? At minimum, a Grabby civilization harvests stellar energy. They build Dyson swarms, millions of solar collectors orbiting stars, capturing photons that would otherwise radiate uselessly into space. They might disassemble Mercury-sized planets for raw materials. They construct habitats, computation substrates, manufacturing facilities in orbit around stars. That's the conservative version. That's Grabby light. The aggressive version looks different. Entire star systems dismantled, planets broken down to atoms and reassembled into whatever maximizes utility for that civilization. Stars themselves potentially moved, arranged into configurations that optimize energy collection or enable large-scale computation. The natural structure of a galaxy replaced with engineered architecture. We don't know which version Grabby civilizations pursue. Maybe they're careful. Maybe they preserve some fraction of natural worlds, leave some systems untouched for aesthetic or ethical reasons. Maybe they value diversity, beauty, the original state of things. Or maybe they don't. Maybe once you're thinking on galactic scales, individual planets stop seeming precious. Maybe efficiency dominates. Maybe a civilization optimizing for growth and resource use sees a pristine solar system the way we see an undeveloped plot of land, potential waiting to be realized. The uncomfortable truth is, we can't assume benevolence, but we also can't assume malice. Grabby civilizations might be perfectly neutral, not hostile to other life, not trying to destroy anyone, just expanding because expansion is possible and resources are valuable. But neutral still means transformative. A civilization that's neutral about Earth while expanding through the solar system would process our planet for materials without a second thought. Not because they hate us, because we weren't there when they arrived and they needed the iron. This is critically different from the dark forest model, where the assumption is active threat, predators hunting prey. Grabby civilizations don't need to be predatory, they just need to be present first. The danger isn't aggression, it's indifference. Think about how humans expand across ecosystems. We're not trying to destroy ant colonies when we build cities. We're not hostile to forests when we clear land for agriculture. We're just using resources for our purposes. The fact that we displace other species is almost incidental. Unfortunate maybe, but not the goal. Scale that up cosmically. A Grabby civilization expanding through the galaxy isn't targeting anyone. They're just building, growing, using what's available. If another civilization happens to be in the way, well, that's a problem to solve, maybe through negotiation, maybe through boundaries. But if the territory is empty when they arrive, they use it. The territorial imperative might be completely neutral. No conquest, no empire building in the traditional sense. Just the logical conclusion of, we need resources. Resources are available. We have the technology to reach them. Different Grabby models exist. Settlement, establishing colonies, habitats, preserving some version of the original environments. Harvesting, extracting what's useful, moving on. Complete transformation, rebuilding everything from scratch into optimal configurations. We don't know which model dominates, or if different civilizations pursue different approaches. But here's what we can say with confidence. Whatever Grabby civilizations do, it's irreversible. Once a star system is claimed, once it's transformed or settled or harvested, it's not going back to its natural state. The territory changes hands permanently. Whether Grabby civilizations are predatory or not, the outcome for us might be the same. What happens when two expanding civilizations meet? We've been talking about expansion as if it happens in isolation. Civilizations spreading outward into empty space, claiming unclaimed territory. But the territorial map has edges, and eventually, those edges touch. Two spheres of expansion, growing toward each other at near-light speed, finally intersecting somewhere in the middle. Both civilizations have claimed everything behind them. Both are still expanding forward. And suddenly they're trying to claim the same space. This is the boundary problem, and it's inevitable in any universe with multiple grabby civilizations. The question is, what happens at that boundary? One possibility is negotiation. Two civilizations, both technologically advanced enough to expand across star systems, meeting and deciding to establish a border. You take this region, we take that region. A cosmic treaty. The expansion stops, or redirects, or both sides agree to share. This sounds civilized, diplomatic, the kind of outcome we'd hope for. But there's a problem. Negotiation requires communication, and communication is limited by the speed of light. If two expansion waves are moving at significant fractions of light speed, the civilizations behind them might not even know they've met until long after the collision happens. The frontier probes make contact. They're self-replicating machines, following programming, claiming territory according to instructions given potentially millions of years ago by a home civilization that's now millions of light years behind the expansion front. Do those probes have authority to negotiate? Can they even recognize another civilization's claim? By the time information about the contact travels back to the homeworlds, by the time deliberation happens and instructions are sent forward, the situation at the boundary could have already evolved in unpredictable ways. Another possibility: conflict. Not war in the traditional sense. These might not even be biological civilizations anymore, might be AI-driven expansion processes that don't care about conflict the way humans do. But competition for the same resources, incompatible claims to the same star systems, probes trying to settle the same territory. Game theory suggests first arrival matters enormously. Whoever reaches a contested system first has possession. The second arrival faces an occupied territory. Do they challenge that? Do they accept the boundary where it stands? The incentive structure favors whoever moves faster. If you know other civilizations might exist, if you know boundaries will eventually form, the optimal strategy is to expand as quickly as possible to maximize your territory before those boundaries lock in. This creates a race dynamic even without direct competition. Even if civilizations never communicate, never knowingly compete, they're still racing against the possibility of future boundaries. Faster expansion means larger territory. Larger territory means more resources, more security, more long-term potential. And here's where being a late starter becomes catastrophic. If you begin expanding after other civilizations have already claimed significant territory, you're boxed in from the start. Your expansion hits boundaries quickly. Your potential territory is a small fraction of what the early starters claimed. The civilizations that started expanding just a few million years earlier might control volumes of space 1,000 times larger. Not because they fought for it, not because they conquered anyone, because they arrived first and the territory was unclaimed. This is the leverage problem. Late arrivers have no bargaining position. They're expanding into a universe that's already being divided. The deals available to them, if deals are even possible, are whatever the established grabby civilizations are willing to offer, which might be generous, might be fair, or might not. We like to think contact with alien civilizations would be momentous, meaningful, a profound meeting of minds. But in the Grabby model, contact might be bureaucratic, prosaic, two expansion processes intersecting at a boundary, establishing a border and moving on. No grand philosophical exchange, just territorial division. Or worse, contact might be accidental. One civilization's probes arriving at a star system only to find another civilization's infrastructure already there. Sorry, this one's taken. Try the next galaxy over. What happens at these boundaries will define the cosmic political map for billions of years. Whether through negotiation, conflict, or simple recognition of possession, these borders will determine who controls what, and once established, they're likely permanent. Because once territory is claimed and infrastructure is built, reversing that becomes enormously costly. You don't unclaim a Dyson swarm. You don't dismantle millions of habitats and give the raw materials back. The status quo at the moment, boundaries form, tends to lock in. But there's an alternative to collision if we move fast enough. Grabby Aliens theory makes a radical claim. Expansion isn't optional. Not if we want a future beyond our solar system. Not if we care about humanity's long-term potential. Not if we're thinking on timescales longer than centuries. Here's the stark reality. Staying on Earth, or even staying in our solar system, guarantees cosmic irrelevance. It means accepting whatever fraction of the universe remains after the Grabby civilizations finish dividing it up. It means hoping nothing catastrophic happens to our one planet, our one star, our one basket containing all of humanity's eggs. That's not a safety strategy. That's accepting existential fragility. Expansion offers something fundamentally different: resilience through distribution. A civilization spread across multiple star systems can't be wiped out by a single asteroid, a single supervolcano, a single catastrophic mistake. The redundancy alone justifies the effort. But it's more than just backup colonies, it's resource access, on a scale that changes what's possible. Our sun produces about 4 times 10 to the power of 26 watts of power. Currently, humanity uses about 2 times 10 to the power of 13 watts. We're capturing a tiny, infinitesimal fraction of our own star's energy. Now scale up. A Dyson swarm around the sun would give us access to trillions of times more energy than we currently use. That much energy enables projects we can't even imagine. Mega-scale computation, interstellar travel, potentially physics experiments that require stellar-level power. Now expand to multiple star systems, hundreds, thousands, millions, each one a source of vast energy and raw materials. The resource base becomes effectively unlimited on any timescale humans care about. This isn't about greed. It's about what becomes possible when you're not constrained by the energy budget of a single planet. Medicine, science, art, engineering. Everything we value becomes achievable at scales we currently consider impossible. And there's the security argument. Not security from aliens, security from ourselves. Humanity's greatest risks right now are self-inflicted. Climate change, nuclear weapons, engineered pandemics, AI alignment failures. These are concentration risks, risks that exist because all of humanity occupies one fragile biosphere. Spread across star systems, those risks diminish. A catastrophe on Earth becomes tragic but not terminal. Humanity persists. And with multiple independent colonies, we get evolutionary diversity in how civilizations develop. Different governance experiments, different technological paths, different cultural solutions to universal problems. Some might fail, some might succeed beyond expectations. But the species survives, learns, adapts. Compare this to the dark forest scenario, where the prescription is hiding, staying quiet, making ourselves invisible. That's a purely defensive posture with no upside. If you're right and the universe is full of predators, hiding might help temporarily, but it doesn't solve anything. You're still vulnerable, still constrained, still hoping you never get noticed. Grabby expansion is the opposite. It's active, not passive. It's claiming agency over our cosmic future, rather than hoping circumstances favour us. And here's the philosophical shift that matters. This isn't about conquest. It's about participation. The universe is being shaped, either by us or by other civilizations. We can choose to be part of that shaping, or we can choose to be spectators. Grabby might just mean successful. It might be the difference between civilizations that persist and flourish across cosmic time and civilizations that remain forever small, forever vulnerable, forever hoping nothing goes wrong. The opportunity cost of delay isn't abstract, it's measurable. Every century we wait is galaxy clusters moving out of reach. Every millennium is volumes of space we could have claimed being claimed by someone else, or simply becoming unreachable due to cosmic expansion. We're in the window where expansion is possible, where the frontier is still open, where humanity could genuinely become a multi-star system civilization with access to resources beyond anything we've ever imagined. But that window is closing, not in billions of years, in cosmically short timescales that might matter within human civilization's lifetime. This isn't about whether we should explore space someday. It's about whether we should begin now, while the opportunity exists, while the frontier is available, while we still have the chance to claim our stake in the universe. The future belongs to whoever grabs it. That's not a threat. That's geometry, physics, the mathematics of a light-speed expansion in a finite, reachable universe. This isn't about conquest. It's about whether humanity has a future among the stars or gets locked into a single solar system forever. We're at a decision point in human history that won't come again. Not a decision we'll make consciously in some grand council or global vote, but a decision we're making right now through action and inaction, through whether we prioritize space technology or delay it, through whether we treat expansion as urgent or as something we'll get to eventually. The window is open now, not metaphorically, actually. The reachable universe is at its maximum extent right this moment. The frontier is still mostly unclaimed. The opportunity for humanity to become a multi-system, multi-galaxy civilization exists today in a way it might not exist a million years from now. And the crucial thing to understand is, this decision has permanent consequences. If we expand now, if we begin sending probes and establishing infrastructure and claiming territory while it's available, we secure humanity's access to cosmic resources for billions of years. We ensure that whatever happens to Earth, whether climate catastrophe or asteroid impact or something we haven't imagined, humanity persists. If we delay, if we wait for the right time, or for our civilization to mature, or for our problems to be solved first, we accept a smaller future, maybe significantly smaller, maybe confined to one solar system while the rest of the universe gets divided among civilizations that moved faster. The next few centuries matter cosmically. Not millions of years from now when we've achieved some hypothetical enlightenment. Now, in the time frame where human institutions and governments and space agencies are making actual choices about funding and priorities. What we lose by waiting isn't just abstract territory, it's options, it's potential. It's the difference between humanity having access to the resources of a galaxy cluster versus the resources of one star. That difference matters for everything we might want to do as a species. Every scientific question we might want to answer. Every crisis we might need resources to solve. Every possibility for human flourishing that requires energy and materials beyond what Earth can provide. The Grabby model reframes the Fermi paradox completely. The question isn't, where are they? The question is, when do we start? Are we going to be one of the Grabby civilizations? Or are we going to be one of the quiet ones, the ones that stayed home, the ones that are invisible in the cosmic territorial map because we never claimed anything beyond our own solar system? This is optimistic, not pessimistic. It's a theory that says the future is available. The universe is there. The opportunity exists. We're not doomed. We're not late. We're potentially early, arriving at the cosmic land rush while most of the territory is still unclaimed. But opportunity and urgency go together. The window being open now means we can act. It also means we need to act. Because windows close. The race isn't really against other civilizations, though they might exist. The race is against time itself, against cosmic expansion, against the geometry of a universe where every passing year makes less of it reachable. And unlike the existential threats we usually worry about, the ones that might destroy us, this is a challenge that requires action, not prevention. We don't need to stop something bad from happening. We need to start something good. We need to build, to expand, to claim our future. The Grabby model doesn't predict disaster. It predicts that the future belongs to civilizations that act, that expand, that grab their steak while it's available. We have the technology, or we're close. Self-replicating probes are theoretically possible with near-term engineering. Fusion propulsion could get us to nearby stars within decades of travel time. The basics of what we'd need to begin expansion exist or are within reach. What we lack isn't capability, it's urgency. The collective understanding that this matters now, not someday. That space expansion isn't a luxury we pursue after solving Earth's problems, but a necessity for ensuring we have the resources to solve those problems long term. Every year we treat space as optional is a year the frontier shrinks. Every decade we delay is territory claimed by others or lost to cosmic expansion. Every century is the difference between a large future and a small one. The future belongs to whoever grabs it, not through violence, not through conquest, through presence, through being there, through claiming territory while it's available, and building infrastructure that lasts. This isn't about becoming predators or conquerors, it's about becoming participants in the cosmic story instead of footnotes, about ensuring that humanity, our values, our culture, our descendants, has access to the universe rather than being locked into one tiny corner while others shape what comes next. The starting gun already fired. We didn't hear it because it happened millions of years ago, maybe in multiple places across the universe. Other civilizations might already be expanding, their spheres growing toward us at near-light speed. Or maybe we're genuinely early. Maybe we're among the first. Maybe the frontier is almost entirely open, and we have time to claim a significant stake. We don't know which scenario we're in, but both scenarios demand the same response. Move now, not in panic, not in fear, but with clear-eyed understanding of what's at stake and what's possible. The universe is vast, the opportunity is real, the window is open. The only question is whether we walk through it. If you found value in this exploration, if these ideas changed how you see humanity's future in space, a subscription helps us continue examining the deepest questions about our place in the cosmos. But whether you subscribe or not, carry this with you. We're living in a pivotal moment. Not for survival, but for potential. The decisions we make in the next few centuries will echo across billions of years. The future is still unwritten, the territory is still available, and the race, the cosmic race for who gets to shape what comes next, is happening now. The question isn't whether we can win, it's whether we'll even compete.